Hello, sixth graders. Welcome to sixth grade math, Polygons in the Coordinate Plane lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can draw polygons in the coordinate plane and find distances in the coordinate plane by completing practice problems with 100% accuracy in multiple attempts. Today's objective is find a missing vertex of a polygon given other vertices. We're going to jump right in with example 1, drawing a polygon in a coordinate plane. And let's look at the study tip. The study tip says, after you plot the vertices, connect them in order to draw the polygon. So that in order part is really important, and the book usually gives you those points in alphabetical order, so that's helpful. So our question here is the vertices of a quadrilateral are A, 2, 4, B, 3, 9, C, 7, 8, and D, 8, 1. Draw the coordinate plane. Draw the quadrilateral in a coordinate plane. So the thing to remember is that the first number in your ordered pair is along the x-axis, and the second number is along the y-axis. X is horizontal, y is vertical. And our first step is we are going to plot and label the vertices. That labeling part is pretty important so that we can get them in order. So our next step is we connect the points to form the quadrilateral. So first we plot them. We go across 2 and up 4 for A, and we go across 3 and up 9 for B, and so on with C and D, and then we draw a line to connect. So we start at A and go to B and C and D, and then we go back to A. So we end up with that kind of kite-looking figure. Let's take a look at the key idea. Finding distances in the first quadrant. It says you can find the length of a horizontal or vertical line segment in a coordinate plane by using the coordinates of the end points. So remember, a line segment has 2 end points, so it stops somewhere where lines go on indefinitely. And so our directions for that are when the x-coordinates are the same, the vertical distance between the points is the difference of the y-coordinates. So if you look at the example, we have on the red line, the x-coordinates are the same. They are both equal to D. So to find the length of that line segment, you can subtract F minus G, and you would get the length of that line segment. When the y-coordinates are the same, the horizontal distance between the points is the difference of the x-coordinates. So above the example we just looked at is the one in blue, and you can see that our y-coordinates are the same. They're both equal to B, so we would subtract the x-coordinates, A and C. And you always want to subtract the larger number. You want to subtract the smaller number from the larger number. So in this example, they subtract C minus A. And we do that because we can't have a negative distance. So it says be sure to subtract the lesser coordinate from the greater coordinate because we don't want to have a negative distance. So be sure this all ends up in your notebook. Example 2, we're finding a perimeter. The vertices of a rectangle are F, 1, 6, G, 7, 6, H, 7, 2, and J, 1, 2. The question is asking us to draw the rectangle in a coordinate plane and find its perimeter. So it says, draw the rectangle and use the vertices to find its dimensions. The length, so this is step 1. We are finding the length of the length is the horizontal distance between F and G. So we find the difference in the x coordinates because you can see that the y coordinates are the same. So they're both 6. And so we subtract 7 minus 1. The difference between the x coordinates, 7 minus 1, is 6 units. So the length of the top and the bottom is 6 units. And the study tip over here says you can also find the length using vertices H and J. So you could have done that. It would have been exactly the same. And you can find the width using vertices F and J. It doesn't matter because it's a rectangle, so they're the same. So step 1 was finding the length. Step 2, we're going to find the width. The width is the vertical distance between G, 7, 6, and H, 7, 2. So we see that our x coordinates are the same. So we need to find the difference between the y coordinates. So we're going to subtract 6 minus 2, which equals 4 units. And then our third step is finding the perimeter. Step 3 is calculate the perimeter. And we do that by multiplying 2 times 6, because we have two sides that are 6 units long, and 2 times 4, because we have two sides that are 4 units long. And then we find the sum of those two sides. So 2 times 6 is 12, and 2 times 4 is 8, and we add that up, and we get 20 units. Example 3 is our real-life application. Don't worry about the giraffe. He's okay. His head is on the next page. In a grid of the exhibits at a zoo, the vertices of the giraffe exhibit are, and it shows them there for you. I'm not going to read them all. The coordinates are measured in feet. What is the area of the giraffe exhibit? So that's our job, is to figure out the area of the giraffe exhibit. So don't get that confused with perimeter. So step 1, we are going to plot and connect the vertices using a coordinate grid to form a trapezoid. So we go across and up to all the different coordinates, and we plot those points. And so you can see that done for you on the coordinate grid over here. And then we are going to use the coordinates to find the lengths of the bases and the height. So base 1, up at the top, the y coordinates are the same, so we subtract the x coordinates to find the length of base 1. So 60 minus 0 is 60. So that's the length of base 1. Base 2, at the bottom, again, the y coordinates are the same, so we subtract the x coordinates. 100 minus 0 is 100, so that's base 2. The height is going to be going the other direction. So if we look at points E and H, we can see that the x coordinates are the same, so we're going to subtract the y coordinates. 90 minus 30 is 60, so that's our height. And our next step is use the formula for area of a trapezoid to find the area of the exhibit. So remember, area of a trapezoid is 1/2 times height times base 1 plus base 2. So when we substitute in our numbers, this is what it looks like. And then we simplify that. So we add 100 plus 60, and we multiply by 60, and we divide by 2, or multiply by 1/2, same thing. And remember, you can take half of any of these two numbers. You can take half of 60, or you can take half of 160, and then just multiply the two numbers that are left. However you do it, if you do your math correctly, you should come up with 4,800. So the area of the giraffe exhibit is 4,800 square feet. Let's look at this common error box. It says you can count grid lines to find the dimensions, but make sure you consider the scale of the axes. So if we look at this, every jump is not 1. Every jump is 10 feet. So it's fine to count, but you have to be sure that you know what you're counting. So if you're counting from E to H, you don't have 6 feet, you have 60 feet because every jump is 10 feet. Remember, to complete your lesson, you need to be sure your notes are complete in your ISN, do your Google form questions, review your lesson if you need to, complete your Big Ideas math assignment in your Math Spiral notebook, and submit that when it is 100% correct, not before, and be sure you track your progress on your playlist.